Eric Burgess here, and we've been given the task of verifying that sine cubed theta plus cosine cubed theta is equivalent to the quantity cosine theta plus sine theta times the quantity 1 minus cosine theta sine theta. So looking at this, let's just go straight for the proof, and if we get stuck, we'll go and do some exploratory stuff and then come back and try and finish up writing out the formal proof. A common mistake I'm willing to guess a lot of students will make is they'll factor these cubes out. But that is an illegal operation because of this plus sign. So if these were being multiplied together, you could totally take a cube out and then maybe do some stuff with some additional identities. But here, that would not be the case. I think it'd be easier to work with this side and get it to look like the left-hand side. So let's go ahead and do that. So we are going to not touch the left-hand side. And we got cosine cubed theta. So over here, well, the first step appears to be multiplying. Let's go ahead and distribute. So let's write that out. Distribute. That's going to be our justification on this line. And we're going to have cosine theta, because that's going to be times 1, minus cosine squared theta sine theta plus sine theta times, or in this case it's just going to be minus cosine theta sine squared theta. All right, so looking at this, there's two things that sort of pop out at me. The first is this looks surprisingly like a double angle identity, but then you got to ask yourself, what is our goal? Where are we trying to go? And we're trying to get to these cubes over here. And so it wouldn't make sense to use a double angle, at least not initially, because we would be going down in power. So looking at this, instead it would make sense to use a Pythagorean identity. Plus the double angle, we'd have to do a lot of work to make it look the same so we could use it. So here we're going to use a Pythagorean, and what we could do is we could replace this cosine squared with a 1 minus sine squared, and we could replace the sine squared with a 1 minus cosine squared. And when we distribute these sines and cosines in, we're going to get that the cube, and we'll get an extra sine and cosine out, which will possibly cancel with these, and that could get us to the same form. So I can sort of see where we would go with that one. So let's go ahead and go down that route. So we're going to use the Pythagorean identity. So I'm just going to write that here, Pythagorean identity. And I'm going to write this side a lot smaller so we have room. So we're going to have sine cubed theta plus cosine cubed theta is equal to, and we're going to have a cosine theta minus, and this is going to be 1 minus sine squared by the Pythagorean identity, theta, times sine theta plus sine theta minus cosine theta times, and this is going to be 1 minus cosine squared theta from the Pythagorean identity. All right. Up next, we're going to distribute. We're going to wind up with sine cubed theta plus cosine cubed theta is equal to cosine theta minus, and this is going to become sine theta and minus sine cubed theta. Oh yeah, this is going to be gorgeous. Plus sine theta, which will cancel out with that sine theta over there, minus, parentheses, cosine theta, when we distribute, minus cosine cubed theta. I left this negative on the outside, so that's why it's not a positive yet. Yeah, just be careful with your negatives and stuff. All right, so from here, we can go ahead and say, technically there's another distribution step. I'm just going to leave that implied for the reader, which could be considered, if we want to be really, really rigorous, we would write every last thing down. But we're going to just go ahead and write simplify, combine, reduce, all those sorts of things. So we're going to have sine cubed theta plus cosine cubed theta is equal to, and when we distribute this sine, well, actually, let's distribute out here. So we're going to go cosine theta minus sine theta plus, let's be really rigorous, what the heck, sine cubed theta plus sine theta minus cosine theta plus cosine cubed theta. So this step is really distribute, and then we're going to combine like terms. I'm going to call that CLT. We're going to get sine theta cubed plus cosine cubed theta is equal to, the cosine and cosine will cancel, the sine and sine will cancel. I forgot a parenthesis here. And we're going to be left with sine cubed theta plus cosine cubed theta. Is that the same thing? Yep, it is the exact same thing. And so we could say, there you go. So this would be the verification that you would have. If you have any questions about this, feel free to drop a comment down below, subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.